Hello, and welcome to Percona Virtual Days. This is a talk about encryption with Percona server for MySQL. This gentleman here is Peter Sylvester, also known as Sir of Sir. I would like to thank him for his support on this presentation. He presented this topic in the North American time zone. This is me. My name is Kedar Vaijnapurkar. I'm presenting this topic here from Vadodara, India. I am one of the Tier 2 DBA at Percona since little more than a year. I have over 15 years of experience in open source technologies. In this webinar, we will talk about how to secure your data using various encryption methods in Percona server. 2 points that generally required for meeting regulatory requirements for data security are encryption of data at rest and encryption of data during the transit. The main focus of this talk will be about encrypting the data at rest, but we'll also touch base with the encryption for the data in the transit. Normally, the word compliance is mapped with other words like PCI, HIPAA, GDPR that suggest you standard for data protection. But recently, I have come across articles which discuss about the preparation for data breach, not preparation, not prevention. This is a changed perspective. There seems to be equal discussion out there regarding how to prepare and respond to a data breach, as there is a discussion about prevention for the data breach. This is an indication that we should be prepared for the data breach and work for data protection. Regardless of what protocols you may need to follow, you simply need to accept that the breach attacks are more common than ever, and all you need to do is work to protect your data. Data encryption is one of the most effective way that you can use to solve this purpose. This webinar is going to help you navigating through the encryption options here. All right, with that introduction, let's start the talk about the encryption and a brief talk about encryption of a data in transit. So, data in transit means any data that is flowing in and out of database servers. As we know, the MySQL clients or applications that connect to MySQL server, as in client-server application architecture, they request, add, or modify the data, and between the transit, the data is unprotected. As a database administrator, it is our responsibility to ensure that the data remains encrypted as it goes out of the server while it is in transit. Now, MySQL supports encryption between the client and server. Like it supports this using the TLS, Transport Layer Security Protocol, or also referred to as SSL here. Implementing and ensuring the encryption for data in transit is easy to follow. I have included the link here in the slides. Once you follow the steps there, and upon setting that up, like you can consider yourself compliant for the requirement of encrypting the data in transit. Like whether it goes in and out of server, the data is encrypted. All right, so that was just a brief about the data in transit, but the main talk is about the data at rest. So encrypting the data at rest. So in this approach, like we will approach this discussion about encryption by answering the various different ways for the data that can be accessed by bad actors, like they are noted here by 3 points. One is when someone may have an access to your physical hard drive or physical hardware like hard drive or your laptop. When someone may have an access to the system, like not database, but the system via SSH or remote RDP. And finally, when someone has an access to your database instance itself, like they have the connectivity and then connect to the MySQL instance. So let us start with the first case here, the physical security compromise. This gentleman here would love to have your data, whether they are on your laptop or whether it is on your hard drive. It is uncommon that we may have the critical databases stored on the laptop, but it still can have other critical information. Also, it is difficult to have hard disks to be stolen, like disks to be stolen due to proper data security, data center security these days. Or also, like the databases these days are like spun up on the cloud, like AWS, Azure, GCP, or other cloud vendors. So it is difficult, but still it may happen. And physical data security is still very much important topic that we should answer to. The good news is here that the solution here is comparatively easy to deal with, or comparatively easy to implement. The common solution here is like encrypt the entire volumes. So like some of the common encryption options are listed here, like uh, listed here in the bullets. Note that the BitLocker and File Vault are listed for the sake of formality, but as you may know, like they are more common for the end user level encryption needs for your laptop, etc., but not really for the other things. Moving ahead, the limitations. So there are some limitations when we go ahead with this approach. The main limitation comes from the fact that once the file system with the disk is attached and decrypted, the whole encryption decryption process becomes transparent to the file system level, meaning that once you have an access to the system, it can see, like you can see the fully decrypted data, like the data is in decrypted state. You can access it, you can read it, you can download it, you can access it as if there was no encryption in place. So the file system level encryption does not protect you. If someone has an access to an already running server with the volume decrypted, at this point you need some advanced protection, advanced technology or advanced option to protect your data. And that brings up us to the next point here, and that is how to protect if someone gets an access to the file system, like let's use say using SSH, using RDP, because in that case the system is already decrypted and everything is accessible. Okay, we are not talking about that someone has an access to a MySQL CLI, but the SSH or RDP access to the file system data. The solution here is what Percona offers by transparent data encryption. This is also referred to as data at rest encryption for InnoDB, as you may look into the documentation pages. This solution to the TDE is available in Percona Server 5.7 and other MySQL flavors, if you can see on the slide noted. The transparent data encryption technique encrypts the InnoDB tablespace individually. The table spaces are the data files that resides under the data directory holding the data, and each table space will be encrypted using its own encryption key. Now let me elaborate this a little more in the next slide with a figure. As we can see in the picture here, the table 1.ibd represents an InnoDB table in MySQL. Each table space has a table space prefix, or you can say a header. This is stored in the very beginning of the table space, like the header, or so the prefix is stored in the very beginning of the table space. When we implement the transparent data encryption at database level, it will note the encryption key for this table, and that key will be used to say encrypt or decrypt the data as if the data moves in and out of the table. This key is stored in the header section. Now each table has its own encryption key, also known as the tablespace key. The tablespace keys are also written in the tablespace headers, as I already said, but that will be insecure. Why? Because they are unencrypted, and hence the tablespace keys also need to be and need to be encrypted using a master key. And this is referred to as a two-tier architecture that TDE works with. So here in two-tier architecture of transparent this TDE data encryption, we have a single master key, and then we have individual table space keys. They are all working together to encrypt the database table spaces. When MySQL is started, the master key is used to decrypt the table space keys from the header of underlying table spaces. Like this process is done for like each and every table spaces. Like all the table spaces will have their own table space key. So this process is done for every time MySQL is started, and master key and table space keys in work hand in hand to decrypt the data when MySQL is started. These keys, when decrypted, are stored in memory. So like if you see this table here, like uh, every time a data access request comes in, MySQL has the keys in memory table. So like they can use this key directly to encrypt and decrypt the data as needed. Now, this two this two-tier architecture provides us with an advantage, and that is the master key rotation. Like key rotation depends on the security protocols that is being followed. Like you may want to rotate the key every few weeks or maybe a couple of months. But if we don't have the two-tier architecture, what we may need to do is like upon key rotation, you will have to encrypt all the table spaces individually, and that would be really lengthy process. Why? Because it will have to rewrite the table spaces with the encrypted data by the new key. But since we have this two-tier structure, we use the command listed here, like master key rotation, alter instance, rotate master key. What happens is when you execute this, the master key regenerated will re-encrypt the table space keys from the header, and that is it. Like it doesn't need to re-encrypt everything else. It's just re-encrypt the table space keys, update the memory table, and then that is it. This operation, like this two-tier architecture, makes the key rotation very fast operation then. Okay. Now, okay, so we already know that the table space keys are encrypted and are stored in the table space header, but what about the master key? It is lying out somewhere. So Percona offers two options here. One, store the master key on a local file system, and two, use a remote key management system to hold the master key in a key management system like Vault. In our case, it is Vault. Now, using the first option, like storing it in a key ring file, the master key is on the local file system. So it is okay to use this, like storing the master key on the local file system for development and proof of concept kind of solutions. But it is really seen as an unacceptable solution for the compliance purposes. So like in production environment, I wouldn't accept the keyring file option to be used. So for compliance, we needed, like earlier we noted, like GDPR, PCI, HIPAA. You want to consider Vault as a solution opposed to using the uh, keyring file option. So how do we encrypt a table? Well, it is really an easy task using a command line listed below. Like you just have to do like alto table encryption is equal alto table table name encryption is equal to y. All right. Uh, Even though it is an easy task, it is not going to be easy on database. The table will be fully rewritten. Why? Because it has to encrypt the whole table space data and rewrite it. Thus, it will not be an online DDL operation. But we all know that the Percona PD online schema change tool is going to help us here. Like you can use the PD online schema change tool to ensure the data is available while the encryption is happening in the back, and then you can just swap the table. Okay, now how do I know what table spaces are encrypted? So the table spaces encryption status is reflected in the information schema.tables table. And you may require to identify that which one of the tables are encrypted using the query listed here. You might, if you want to like list which are not encrypted, then you can use the not like operator as well. All right. So since we are talking about encrypting the individual table spaces with their keys, we surely have to think about possible performance implications. But good news here is that the performance implication of the transparent data encryption is fairly minimal. Reason being, the data is encrypted when the data is written to the table space and decrypted when it is read from the table space. Like data is stored in the buffer pool. Whatever data is stored in the buffer pool is in a completely decrypted state. So we have done a performance benchmarking already here. The chart here, if you see, is like the shows up as throughput versus number of threads. We did like this benchmarking results are for the benchmarking of a smaller buffer pool instance. Like when we say a smaller buffer pool, that means you have to read the data from disk. Despite the fact when the data is being written from the disk, we do not see much of a difference between the TPS counts for each of the number of threads that we have performed the tests for. The performance is fairly comparable for the database with or without the encryption. The next slide is for the chart for the larger buffer pool tests, and again the graph shows the performance impact for is like negligible, showing the negligible difference. Here, when even if the buffer pool is larger, obviously there is greater chance the data is always being in memory, and thus a little pressure to encrypt and decrypt the data. But similarly, we don't see really much of a difference in performance when we use the transparent data encryption here. Okay, now that we are having the advantages and seeing that it is really performant, what are the limitations? Much like file system level encryption, where you can connect to the system, access to the system, data appears to be not encrypted at all, as it is already like it is already decrypted. Similarly, the transparent data encryption, where you log into MySQL, you'll be able to see the data fully decrypted. Why? Because the MySQL has the master key, decrypted all the table space keys, and it is stored in the memory. If you fire a query, you will get the data in unencrypted state. What we need to do here is to protect your data from this kind of database access, like unauthorized access, is implementing the best practices for the user access. But okay, before that, let's have a demo here. After the talks like all we had about the secure way of implementing and transparent data encryption, let's just first see how much effort this is really to implement this. In this demo, we're going to go over a recording. I'm not really going to do the live demo. It will be a recording of a session, and we will run it a little faster in order to save the time. So demo is recorded. It is played at a speed, but there's a Percona blog they're going to share with you that will have all the steps I have performed here. All right, so let me bring it up. Okay, so we already have a yum repository configured here, and we are installing the vault itself. Once the vault's installation is done, we'll go ahead and work on setting up the SSH keys, SSL keys, which will be used for the communication with the vault. I have used the configuration I just used from the Percona blog itself. Now we will create, okay, the keys are ready. Then we are going to create the vault configuration. Okay. Now we will configure the vault to listen to port 8201 for encrypted connection, while we will listening on port 8200 for the non-encrypted connections. Configuring the non-encrypted port is just for the sake of simplicity of this demo, but in production environment, I strongly recommend using the encrypted connection settings only. If you can see here now, I'm specifying the address above. Then below that, there is a certification file and a key file that denotes the connectivity with the that helps accepting the encrypted connections. And okay, here is the clean version of the configuration file with all the comments removed. There you go. With all the configurations set, now let us start vault and verify the status again. Since we are having vault up, let's start the setting the configuring the environment variables to communicate with. We specify the vault address, then we go ahead and initialize the vault here. We're going to put this output to a file for further reference, but make sure that we keep this file secure, since it has the unsealed keys and initial root token that allows you to connect using root. Here you go. Those are the secure things that we need to hide from the world. Now we will go ahead and unseal the vault. We have to do this operation 3 times, like with 3 different unsealed keys that we received earlier. And if we want unseal, the vault will be considered as in a sealed state, meaning that it is not going to respond to any requests. Now, okay, so that is done. And now we're going to log in vault as root. That is a password that we have received earlier. So to work with the MySQL, now we have to create the policy for MySQL. This policy will allow the read and write access to secrets stored in the vault for specified MySQL locations. All right, I just copied the configuration from the blog. Now we'll apply this policy, and we also need a token so that we can access this policy, and that configuration will be used while we'll use configuring my.cnf here. So let us see what token information we have here. Okay, we'll save it for future references. So now we'll move ahead and start the say secrets engine that will allow us to store the secrets, and then we'll move ahead to configure the MySQL. So here we are going to specify where the plugin is and where the vault configuration file is that MySQL is going to use to communicate with the vault. Here we also need to download the SSL certificates for MySQL. Okay, so using these certificates, MySQL will be able to communicate over port 8201 with the SSL. Okay, now setup for vault configuration. Now I'm going to grab the configuration for vault again from the blog post. Since like we have the vault running, we have our keys in place, and now we are preparing the vault configuration. We are just going to replace the like vault URL in the token that we received earlier here. And now it's time to start MySQL to apply the changes. So upon when we'll start MySQL will be able to connect the vault using the configuration we've already provided, but it will still not have the master key. So to generate the master key, we are going to use the alter instance rotate inodb master key. So this is the same command, the rotate for rotation and generating the initial master key. This key will be stored in the vault. What we are doing here now is preparing a dummy table with sample data, and we are going to demonstrate how to encrypt a table space here. All right, inserting dummy data here. Okay, so that is it. That's the encrypted table with the vault configuration. Our encryption using vault is ready, integrated with Percona server, and I'm sure like you didn't get chance to note the command since like we were literally running through the steps. So do not worry, we have the plenty of content available through the documentation, as well as we have the blog post sections that you can follow to implement this setup. Okay, so now let's go back to our original discussion. Okay, so we were talking about three different ways of possible system compromise. So we talked about physical compromise, we talked about terminal compromise, but now is the time to talk about the MySQL session compromise. This situation, the session compromise, is when someone has an access to your MySQL database, like someone actually has logged in to the MySQL database using credential. Now, it is not about like physical file system access to the data directory, but it is about connecting MySQL using a session and establishing a session. So as like in previous encryption solutions, this is also like a transparent when you are logged in. Like this is something very common, right? Like people are like aggressively digging for the new age gold, and that is your data, where if someone gets an access to your MySQL, it's the easiest way that they can just select star or select into out file, and somewhere it can fetch the data. And this has been very, very common these days. Like I have personally witnessed when I was working with Peter already, on his GCP cloud instance, where there was no firewall setup, since it was like just a proof of concept. We were discussing something, and the password we provided was really weak. So like within 24 hours when we came back, there was a welcome message for us when we on the login prompt, like, okay, if you have we have your data, and if you want it back, like we have to pay Bitcoin in so and so address. So like we were lucky that the data was dummy, but we could have used this strong password or like firewall from saving us from this situation. But if you have any concern regarding your security for your environment, you can always reach out to Percona. Like we can do a security review, let you know what is the status, and if any corrective measures are required matching with the best practices. So TLDR is like, remember that there are people out there using this like most common approaches to compromise your session security, and sought after your data. Okay, so now with that, like, there is one more thing that we can do if we have to counter the session security, and that comes by encrypting the data on the application level. Like if the database has encrypted data itself, um, it's really difficult. Like even the session security will be able to decrypt it, because the encryption logic lies on the application side. How we can do is like we can leverage the AES encrypt and AES decrypt functionality of MySQL and use a standard key. But remember, like this is an option, but if you decide to use these functions, there are some considerations. Like first is like column sizes. Encrypted data size will be larger than the unencrypted or the original data. So if you do not adjust the column size accordingly, there are like mostly the data will get truncated, and you will get a data loss. Like let's take an example. If I want to store, say, the word data in a column length 3, then you will only get, when you do select star, you'll only get DAT as an output. Now you are getting at least first 3 characters, but when in our case, when we have enabled an encryption, the table, the data that is encrypted, the string gets truncated. This is never going to get decrypted correctly. So this is a totally data loss. So make sure that you adjust your column length accordingly. There is a formula that I have kept it here for your reference. Use them wisely. Um, Also note that since the data is encrypted, it will be difficult that to leverage the advantages that the secondary indexes come with to improve the query performance. Like I'm not saying you cannot use it, but there are limitations here. Like you may have the secondary indexes, but it will be only for a case sensitive equality operators direct searches. So here you are directly comparing like the encrypted value with an encrypted value in the database. Like if you want to do anything other than an equality operator, then like say a like range, the secondary indexes are of no use. Now so this functionality and limitation brings much of a complexity in the design of the solution, and most of it is like driven from the application side. So this is why like the transparent data encryption provided by Percona is considered to be an acceptable say middle ground or acceptable choice for all of the 3 data compromise scenarios that we have discussed so far. Okay, so we talked about data inside the database, but what about data that lies outside, like what are not inside the table spaces, right? We have so many things that lies outside the table spaces. That is like the G system table spaces, your general log, audit log, your temporary table spaces, DDL, temporary files, redo or undo logs, binary logs. Did I say that? So on and so forth, right? So with Percona sort of 8016, we have new encryption features to decrypt all of these files listed here. But again, these two have a limitation. General log and edit logs, we cannot encrypt it so far. Just note that audit log encryption is supported in MySQL, but it is only for enterprise edition. So the workaround for general log and audit log I would suggest here is like you can encrypt them then while they are not really actively written. So for example, you can rotate the general log and audit log and then perform your encryption. So okay, that's that. What else is else that we are storing? So yes, backups are something we store which is outside the databases. So what about them? uh, Starting with easy points, if we are already using the transparent data encryption, the backups are already encrypted. Extra backup provides online physical backup, and it copies the data files which are already in encrypted state. So if you are using TDE, you are secured with the backups as well. One thing I need to note here, like when we are using TDE encrypted backups, in the prepare state of backups, when you want to do the restore, when we restore the extra backup, you have to apply the redo log changes to the table spaces that were taken while the backup was being taken. So for this to happen, the table space need to be like unencrypted or say decrypted state. So extra backup has the parameter that can come handy here, which will communicate, like which will point the extra backup to the vault configuration. It will grab the master key and proceed with the preparation for the backup restoration. Now, but if the backup is like the data is not encrypted on the MySQL itself, then you will have to consider encrypted the extra backup tool using the extra backup other parameters that are there. I have the link in the description here that you can follow for the same. What about logical backup? We talked about physical. What about logical? So in logical backup, if you are using the AES encrypt and decrypt functionality, the application level encryption, then the logical backup will also have the encrypted data fast, and this way this backup is also can be considered as encrypted and safe. But what if we are not using AES encryption functions? In that case, the this is not encrypted. Like the logical backups are obtained basically by connecting the database. So as a client, and it reads the data unencrypted, stores it as an unencrypted SQL format. Now, whether you use the TDE or not, the data is like, even if you're using TDE, the data is in is transparent to the session, right? So you can always read it, and that is not encrypted. So your data or your backup is going to lie, say, unencrypted for the duration you have taken the backup. But then once the backup is done, you can proceed with the backup encryption. Here I have listed 3 of the options like GPG, CC encrypt, and 7Z, and you can encrypt your backup that way. Okay, so now Percona offers the encryption options that we discussed earlier are enterprise level. What I mean here, like when we are looking at the encryption features that MySQL is providing, we are looking at enterprise version of a MySQL. But the Percona MySQL offers these very features free of charge via the open source model. So we have the table here. You may refer to the table for the features comparison and the uh, between Percona and MySQL. In conclusion, so data breaches are getting increasingly common. The narrative today is not really talking about prevention, but also preparing for the breaches. So if you haven't considered enough for security of your data, there has never been a better time than now. Percona is here to help you with the enterprise level encryption feature to easily implement and secure your data. Thank you and have a good day.